questions 11 through 20 on the 2011 grade 10 Cayley math contest. The operation symbol is defined by A, B, symbol CD is AC plus BD. For example, 1, 2, symbol 3, 4 is 1 times 3 plus 2 times 4, which is 11. The value of 3, 1, symbol 4, 2 is. We will follow the same definition, of course, that they give us in the question, and that is this one right here. So this will be equivalent to AC, which is 3 times 4, plus BD, which is 1 times 2. So that is 12 plus 2, which is 14. And therefore, number 11, the answer is D. The circle graph shown illustrates the results of a survey taken by Cayley High School Student Council to determine the favorite cafeteria food. How many of the 200 students surveyed said that their favorite food was sandwiches? Well, pizza is labeled already as 30%. And in terms of a number, remember it's 200 students, so 30% of 200 is 60 students. And then cookies, they don't actually give you a percentage, but they give you this little symbol, which is a right angle, 90 degrees. And 90 degrees represents a quarter, 25%, a quarter of a circle. So 25%, because remember, the whole angle all the way around is 360, and they've told you that's a right angle. So it's 90 over 360, and that is 1 over 4, which is 25%. So 25% of 200 is 50. And then the fries, they have labeled as 35%. So 35% of 200 is 70. So now we have to figure out how many are choosing sandwiches. Well, so far, what is our tally here? 60 plus 50 plus 70 is 180. Well, there's 200 students, so that means the remaining 20 must have chosen the sandwiches. So, and that is 10%. And it all adds up. So number 12, the answer is B. In the subtraction question, K, L, M, N are digits. What is the value of K plus L plus M plus N? Well, let's take a look here. L minus 1 is equal to 1. So L obviously must be equal to 2. Then let's look at the next column. 3 minus N is equal to 5. So that means that N is equal to minus 2. But obviously it can't be minus 2 because N is a digit, positive digit. So what's the problem here? Well, it's probably not 3, it's probably 13, right? Because they carried the 1. So that means that N is equal to 8. That obviously makes much more sense than minus 2. Moving right along, the next column, remember we carried the 1, so it's not K this time, it's K minus 1. Remember we carried the 1 to make this a 13. So it's K minus 1 minus 4, and that is equal to 4. So that means K minus 1 is equal to 8, and therefore K is equal to 9. And finally, 5 minus M is equal to 4, and therefore M is equal to 1. So we've got K plus L plus M plus N, so that is going to be, in terms of all these numbers, K is 9, L is 2, M is 1, and N is 8. So that is 20. So number 13, the answer is A. On the number line, points M and N divide LP into 3 equal parts. So what is the value at M? Well, first we need to figure out the distance from L to P, and we can do that by subtracting 1/6 minus 1/12. Get a common denominator, and we get 2 minus 1 over 12, which is 1 over 12. And then each of these are equal, 3 equal parts, so we'll figure that out pretty simply by multiplying this by 1/3. So that's 1 over 36. So each of these is 1 over 36. That's 1 over 36, that, and that. Now to figure out M is right here. m minus 1/12 has to equal 1 over 36. That's how you figure out the value for m. So m will be 1 over 36 plus 1 over 12. Multiply top and bottom by 3, and you get 1 plus 3 over 36, and that's 4 over 36, which is 1 over 9. And therefore, number 14, the answer is C. The points Q, 1, -1, R, -1, 0, S, 0, 1 are the three vertices of a parallelogram. The coordinates of the fourth vertex of the parallelogram could be. Well, let's graph this and see what we get. So they've given us a few. 1, -1, so approximately here. If this is 1, this is -1. And then they've given us -1, 0. So -1, 0 is right here. And 0, 1. So 0, 1 approximately here. And they're saying that these 3 points add up to form part of a parallelogram. So this, and this. Okay. Well, we have actually more than one way of doing this. That's one way. If you do it that way, of course, the other point's got to be somewhere here, right? It's got to match up like that to make a parallelogram. So how we figure that out is just kind of counting. To get this point, we went 1 down and 2 across, right? So very similarly, to get that point, you'd go 1 up and 2 across from here. So if you do that, you'd get up to, this is going to be 2, and then going 2 across that way would be -2. So that point is -2, 2. And that's, interestingly, answer right there in front of you. There's also 2 others. If you draw it in a different way, 0, 2, and 2, 0 also would create a parallelogram with the 3 points that they give you in the question. But those are, interestingly, not part of the answer choices. So the only one that is -2, 2. So number 15, the answer is A. A gumball machine that randomly dispenses 1 gumball at a time contains 13 red, 5 blue, 1 white, and 9 green gumballs. What is the least number of gumballs that Wally must buy to guarantee that he receives 3 gumballs of the same color? So we have 13 red, 5 blue, 1 white, and 9 green. So let's see how we can do this. Guaranteed. So let's say when he first chooses his first 4, it ends up each color. So 1 red, 1 blue, 1 white, 1 green. So far, obviously, we do not have 3 gumballs of the same color. But we have exhausted the whites. Now we continue in this way. Let's say our next round we choose a red, a blue, and a green. We can't choose a white because there was only 1 white and we already chose it. Again, we have not reached 3 of any same color. But the very next choice, whether it's a red, whether it's a blue, or whether it's a green, it will guarantee that you've got 3 of the same color. So how many do we choose? 1, 2, 3, 4, 5, 6, 7, 8. So if you choose 8, it guarantees that you'll get 3 gumballs of the same color. So that means number 16, the answer being 8, is choice E. Four congruent rectangles and a square are assembled without overlapping to form a large square, as shown. Each of the rectangles has a perimeter of 40 centimeters. The total area of the large square is. Let's start labeling this. Let's call this segment X and this long segment Y. And therefore, this will be X, obviously, since that's a rectangle, and that's Y. And so is that. So each of these rectangles has a perimeter of 2y plus 2x. And they tell you the perimeter is 40. So that means 2y plus 2x is 40. And therefore, y plus x is equal to 20. Now they want you to figure out the area of the large square. Well, the area of the large square is just going to be x plus y times x plus y, right? Because from here to here is x, and therefore this whole side is x plus y. So the area of that big square is x plus y all squared, and x plus y is 20, so it's just 20 squared. So that is 400. So number 17, the answer is C. When 100 is divided by 12, the remainder is 4. When 100 is divided by a positive integer x, the remainder is 10. When 1000 is divided by x, the remainder is. So 100 divided by some integer gives you some number, and then it gives you a remainder of 10. Well, we have several choices for x, right? X can be pretty much anything as long as this is satisfied. But one thing is for sure is that x has to be greater than 10. That's the only way the remainder can be 10. So let's see. If the remainder is 10, then that means that x times this number, 100, let's just say that number is y, would equal x times y plus 10. And that means x times y is equal to 90. So x is 90 divided by y. So any number that matches 90 divided by y could be x. So let's choose something simple. Let's just say y is equal to 2. If y is equal to 2, then x will be equal to 90 divided by 2, which is 45. And like I said, there's several different values that you could choose for x. I'm just choosing one of them. Now we get to the second part of the question, which is what happens when you take 1,000 and divide it by x? What is the remainder? Well, I have set my x as 45. So take 1,000 and divide it by 45 and see what you get as a remainder. And when you do that, you will get a answer as follows. It will be 22 with a remainder of 10. The same remainder. So number 18, the answer is A. And no matter what you chose for x and y, as long as the conditions match, you should be able to get the same remainder when 1,000 is divided by another value of x. In the diagram, triangle XYZ is isosceles with XY is equal to XZ. Also, point W is on XZ, so that XW equals WY equals YZ. The measure of angle XYW is. Well, this is isosceles, so that means these two angles are the same. This one and this one. So we'll call them theta and theta. And therefore this angle must be 180 minus 2 theta. And this angle is going to be an angle that when you add it to this equals 180. So that obviously must be 2 theta. And then this is isosceles. So that basically means that this angle is the same as that angle. So if that is 2 theta, this is 2 theta. And then finally, this, and this must all add up to 180. So that means this angle in here is 180 minus 4 theta. All right. And finally, we take into consideration that piece of information that xy is the same as xz. That's isosceles, so that means this full angle is the same as that full angle. That means theta plus 180 minus 4 theta is equal to 2 theta. And this is the equation that will allow us to figure out the actual value of theta. So this becomes 180 is equal to 2 theta plus 3 theta, so that's 5 theta, and therefore theta is 180 divided by 5, and that means theta is 36 degrees. So number 19, the answer is D. For how many positive integers n with n less than or equal to 100 is n to the power of 3 plus 5n squared the square of an integer? N to the power of 3 plus 5n to the power of 2 is the square of an integer. So m squared, some integer squared. Factor out n squared and you get n plus 5. And that is equal to m squared. Now for this to be a perfect square, we don't need to worry about that because that's already a perfect square. We just have to ensure that this is a perfect square, that n plus 5 is a perfect square. So n plus 5 has to be some perfect square. And the good news is that we don't have to worry too much because n is restricted to being a positive integer less than 100. So we only have to look at squares that are below or equal to 100. Well, let's list those. We got 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100, right? Those are the only ones, only perfect squares. So that means this is k squared, and we have to find the corresponding values of n. Well, let's go through these. If n plus 5 is equal to 1, this guy, then that means n is negative 4. Well, that's no good because n has to be a positive integer. Okay, so that one's not going to work. How about this one? If n plus 5 is equal to 4, then n is equal to negative 1. Well, that's no good. Well, let's try this one. If n plus 5 is equal to 9, then that means n is equal to 4. And then we can easily just figure out all the rest. It's just basically this number subtract 5. No need to write out the whole equation every time. So we got 11, 20, 31, 44, 59, 76, and 95. So these values of n will create a perfect square there, and therefore this will be a perfect square. So how many values do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 values, so therefore number 20, the answer is 8, which is choice B.